Evaluate integral from 0 to pi on 2 square root of sine cube x cos x dx. So, like always, we are to, our interest is to massage a problem to be in this form so that we can continue with our calculations. So, this is a general formula that we use to evaluate beta problems involving sine functions. So, let's continue. So, we can rewrite this whole thing. This square root here is affecting both cos and sine, right? So, integral from 0 to pi on 2 sine, we know that square root of cos x alone is giving us cos to the power half x, right? So sine, let's leave sine for now. So cos to the power half x dx. And this is the case that we now have a sine already raised to the power 3 and now square root adding to it. Let's say if we have square root of a is the same as a to the power half, right? If we have cube root of a is the same as a to the power 1 on 3, right? It means that this one right here is going to be our denominator, right? So what if we have square root of a to the power 3? Is going to be, we know that square root of a is just 1/2. So square root of, 1 on 2. So square root of a already raised to the power 3. That power is going to be a numerator, right? And this one right here, we know is 1 on 2. Multiply 1 on 2, which is same as 3 on 2, right? So fifth root of a to the power 6 is going to give us a to the power 6 over 5, right? So just know that. I'm not writing this very well. And now that sine is already to the power 3, it means that we are going to write it in the form 3 on 2, right? We know the square root alone is coming along with a denominator of 2, which is half. It's just multiplying half by this, which is same as 3 on 2. So now that we have our problem like this, we can go ahead and compare the exponent, the powers of sine and cos to solve for m and n, right? So 2m from the formula 2m minus 1 equal 3 on 2. And how do we solve that? Let's solve it on another sheet so that we get to reserve as a place. So 2m minus 1 equal 3 on 2. So multiplying 2 by 2 to eliminate the fraction. 2 by 2m, 4m, 2 equal 3. So 4m, 2 crossing becomes positive 2 plus 3, 5. Dividing both sides by 4. So my m equal 5 on 4. So and this one, 2n minus 1, 2n minus 1 equal half. So 2n minus 1 equal 1 on 2. Alright. 2n minus 1 equal 1 on 2. So multiplying 2 by 2, 4n minus 2 equal 1. 2 should cross, I'll be getting 4n equal positive 2 plus 1, 3. Dividing both sides by 4, n should be 3 on 4. So now our n equal 3 on our m equal 5 on 4, and our n equal 3 on 4. So now we are comparing to this formula. We know that half beta of mn to give us that, right? So this is to tell us that half beta of m, what is the value for m? 5 on 4, value for n, 3 on 4, should be equal to integral from 0 to pi on 2 sine 3x. You can write it anyway, either in the simplified form or the how it was given. So cos x dx all under the square is sine. So now we are going to evaluate this, and whatever we get will be the solution for this, right? Beta functions. very easy way to solve some integral problems. So we are going to also use the either the relation between beta and gamma, beta of mn equal beta of m, beta of n over beta of m plus beta of n, or we are going to use Euler's reflection formula depending on the nature of the question that we are dealing with, and I'll explain it. So we know that half beta of mn equal gamma of m, gamma of n all over gamma of m plus n, right? So I have beta of 5 on 4, 3 on 4, half beta of 5 on 4, 3 on 4 will give us gamma of 5 on 3, gamma of 5 on 4, gamma of 3 on 4, all on gamma of 5 on 4 plus 3 on 4, 5 on 4 plus 3 on 4. Like as usual, don't forget to bring your half. It's somehow confusing, but now let me leave it for now. When we are done, then we just add it, just multiply through by it. Better so, let me bring it here before we forget. Before you forgot. Is it before you forgot or before you forget? Well, so gamma of 5 on 4, gamma of 3 on 4, let's write that one. Gamma of 5 on 4, gamma of 3 on 4. 5 on 4 plus 3 on 4 is going to give us 2. So gamma of 2. And we know that even if we don't know, we have to know. So gamma of a whole number like this, 5, let me write this. Gamma of n plus 1 equal n factorial. This is used for problems like this. Just subtract 1 from this, give remaining 4. So gamma of 5, you subtract 1 from 5, the remaining 4, so 4 factorial. So gamma of 7, you subtract 1 from 7, 6 factorial. Gamma of 8, subtract 1 from 8, 7 factorial. So now what is gamma of 2? Just subtract 1 from 2, giving us 1 factorial, which is same as 1. So our denominator here becomes 1, right? Okay. So we are left with our half is still there. So we are left with gamma 5 on 4, gamma 3 on 4. Denominator of 1, no problem. So that's it. So now we are left with to evaluate gamma 5 on 4, gamma 3 on 4. And one thing we would like to use is this formula, right? So gamma n plus 1 equal n gamma n. But sometimes when you're trying to evaluate problems using this formula, you're getting strange thing. And that strange thing will give you an indication to try Euler's formula, Euler's reflection formula. So let's try this. So I want a certain number that if I add to n will give me 5 on 3. When we are talking about gamma 5 on 4, we want to evaluate this. So I want a certain number. If I add to 5 on 4, if I add to 1 to give me 5 on 4. So what that number is? So I just equate n plus 1. What is that number? N plus 1 equal 5 on 4. So solving for n here, let me just use a calculator. Gives us n equal 1 on 4. I'm sure you'll be able to solve for this. Or better, so you can just bring 1 here. You can just cross 1 here, subtract, type 5 on 4 minus 1. What you get, you'll be getting 1 on 4. So it means that gamma of 5 on 4 equal n on 1 equal gamma of 1 on 4 plus 1. So I am now able to express this into this form, right? So I will now compare it to the general to the formula. So where is my n? Looking at this, my 1 is here, my 1 is here, my n is 1 on 4. So this is equal to 1 on 4 gamma 1 on 4, right? So I have to continue doing this up to a point that when I'm trying to go further, I'll get a negative number or a half. So let me see if I'm to look for that number that I can add to 1 to get gamma of, to get gamma of 1 on 4, I'll just write 1 on 4 minus 1. You see, I'm getting negative number, so just leave it that manner. So now, simplify this further. We know that gamma 5 on 4 gives us, it gives us 1 on 4 gamma 1 on 4, right? Just right here, 1 on 4 gamma 1 on 4. That was gamma 5 on 4. So we are going to get this one to be 1 on 4 gamma 1 on 4, right? And gamma 3 on 4. Half is still multiplying. So now we are now trying to evaluate this and this, but we have seen that this one cannot be evaluated further. For this question, we are getting negative numbers, so we can leave it that manner. So let's try 3 on 4. 3 on 4 minus 1. We are looking for a number that we should add to get we should add to 1 to get 3 on 4, so that we can just evaluate it. You see, we are getting a negative value, which is minus 1 on 4. It turns out that you can leave your answer in this form, right? But is somehow strange. You might not get your answer when you are solving objective questions, or you might be deducted a mark. Now comes in Euler's reflection formula. So let's leave this for now. For Euler's reflection formula, it says that gamma n 1 minus n equal pi all on sine n pi. So if we have an n and you are able to express this in this form, the form n comma 1 minus n, then you can use Euler's formula and just simplify this problem. So now we have 1 on 4 and 3 on 4. So how can we express this one in this form? How do we know that this problem here has a property that we can try and massage it to use Euler's reflection formula? One of the basic things is to look at their denominators. The denominators will be somehow the same. Now that you've seen that the denominators are the same straight away, they are likely to be simplified by Euler's problem. So, and this is what I'm looking for. I will just take 1 minus n and equate it to any of these here, right? Looking for my n, equate it to any of these here. What I would like is, I would like equating it to 3 on 4. So 3 on 4. This time either 3 on 4 or 1 on 4, you will get the same thing. Even if you don't get the same value, if we evaluate it, we are going to get the same result. So let's try to solve for n. Multiplying through by 4, get 4 minus 4n equal 3, right? If this will cross, then I'm getting a negative 4 here, right? So minus 4n should be equal to 3 minus 4. And minus 4n is going to give me here 3 minus 4 should be minus 1. Dividing through by minus 4. And this is going to give me 1 on 4. So my n is 1 on 4. Since my n is 1 on 4, I can just go ahead and say, now let's forget about, we are dealing with this now, right? So gamma, that is gamma 1 on 4, gamma 3 on 4. And now that we know that our n is 1 on 4, remember we equated n1 minus 1 to this, right? So just leave this one. We're going to get gamma 1 on 4, comma 1 minus our n. We have 1 here minus our n. Our n is also 1 on 4. So at the end of the day, you could see that this side and this side are the same. So if you see that they have the same denominator, try thinking about Euler's formula. So what does Euler's formula state? We are just going to write pi over sine n, and our n is 1 on 4, right? So 1 on 4 pi. What's the value for pi? Let's take it. Pi is 180, right? Pi is 180. So 1 on 4 multiplied by pi is the same as 1 on 4 multiplied by 180. And this is going to give us 45. Then we know that 1 on 4 by pi is 45. We are going to take sine of that. So sine 45. What's the value for sine 45? Square root of 2 on 2. So this expression right here equal pi all on square root of 2 on 2. Now we don't forget our formula and where we are coming from. We now know that a whole of this, we have 1 on 4. A whole of this is pi square root of 2 on 2 multiplying half, right? Yes, that is what we just solved for. So a whole of this, gamma 1 on 4, gamma 3 on 4 equal this right here. So I think we can just multiply this. So 1 on 2 multiplied by 1 on 4 is just going to give us 1 on 8 pi all on square root over 2. So we want to simplify this further. So it can be 1 on 8 pi. Because we want to simplify this fraction, we can just multiply it. We can turn it upside down and multiply it by pi. So this is going to be 2 all on root 2, right? So this can be further written as 1 on 8 multiplied by 2 root 2 pi. Right? Yes. So our 2 here can take care of 8. So 2 here, 1, 2 here, 8. Remaining 1 on 4. So 4, yes. Remaining 1 on 4 here and 1 on root 2. So this will give us pi. The numerator, what is left at the numerator side is just pi, right? So pi 4 root 2. So that's it for this question.